We will now be looking at multiple different rational equation examples of various types with 5 different examples in this video. So for starters, we have our first example here. So our first step would be to find our lowest common denominator or least common multiple. So we have x2 and x. So they all have the lowest common denominator would have to have an x in it, obviously. And it would also have a 2 in it. So 2x is going to be our lowest common denominator. So what we're going to do is basically multiply by 2x, our common denominator, into all these parts. And we're going to do that to try to simplify what we are going to have. So we're going to have every single one of the 3 parts of this equation being multiplied by 2x over 1, like that. So that would mean that we would have 2x times 3 over x plus 2x times 1 over 2 equals 2x times 5 over x. And I'm writing like that specifically so we can kind of apply it to all the problems and not just this one. So you'll notice that we have some things we can divide out. I can divide out x and x, 2 and 2, and then x and x. And that leaves me with just a normal equation to solve without any fractions involved at all. So what that is going to leave me with is I'm left with 2 times 3 plus 1x is equal to 10, like so. So that's just 6. So if I subtract 6 from both sides, I get that x is equal to 4. Now, something we skipped over a little bit that we want to talk about before we move on, though, is our domain. So before we even started this, we definitely couldn't have x be 0, because then we'd be dividing by 0. So our domain of this equation, our possible answers, were that x just can't be 0. And our answer didn't end up being 0, so that worked out very nicely for us. And we can move, that allows us to move on to problem number 2. Pretty straightforward first problem to start with. So now we have a little bit trickier of a problem. The first thing we want to do is probably put a 1 underneath that 7 so we can treat it like a fraction. So the first thing we want to do is figure out what numbers we can't use. So if we look at these denominators, well, x can't equal 2, because we don't want to divide by 0, and we would if we had a 2 in for x. And then we got to figure out our lowest common denominator. So we have a 1, and then both of these have x minus 2. So our lowest common denominator would be x minus 2. So I'm going to multiply all my numerators by that. So I'm going to multiply this whole problem by x minus 2 over 1. Okay, so now we can see everything. So I have 5x times x minus 2 over x minus 2 equals 7 times x minus 2 over 1 and plus 10 times x minus 2 over x minus 2. Now I can see, as the problem we just did, we have things we can divide out. We can divide out x minus 2, and we can divide out this x minus 2, and all those are 1s. All we have left over is 5x on this side of the equal sign. We have 7 times x minus 2, which is 7x minus 14. And then we have a plus 10 on the end. And so if we do some solving here, so subtract 7x from both sides, we get negative 2x on the left, and then negative 14 plus 10 is negative 4. And so if we divide by negative 2, we get our answer is 2. But based on what we started looking at, well, we said that the answer couldn't be 2. If we put a 2 back into our equation, it's not going to work. So that means that this answer, the only one we had, this is an extraneous solution. And that means we are done this problem. There is no solution to this particular equation, no x value that would make it work. Okay, moving on. Problem number 3. So we have, in problem number 3, so the first thing we want to start off with, like we did before, is look at what x's we can't use. So we can't use -1. That would make both of these denominators 0, which is bad. And we also can't use 0 because of this denominator. Second step, our lowest common denominator. Our lowest common denominator here would be x and x plus 1. And that means, like our last problems, we're going to multiply by this across the whole problem. So the whole problem, x times x plus 1 over 1 times everything. And let's continue on. So we have 5 times x plus 1 over what we started with here, over x plus 1 minus 2. So let's just start over. So we have 5 times x plus 1 over x plus 1 minus 2 times x plus 1 over x plus 1 equals 7 times x plus 1 over x plus 1. Same thing. Let's look and see if we can divide things out. We should be able to if we do this right. We can divide out the x plus 1s, these x plus 1s, and these x plus 1s. That leaves us with 5x minus 2x equals 7x. Great. Now, if we combine these, that means that 3x would equal 7x. Only thing that's going to make that work is 0. But we already know we can't use 0. That would make this denominator 0. And so that means that this is another example where the solution is extraneous. And so this one doesn't have a solution, which, as you've seen in lots of different topics, can happen with solving equations. Okay, so make sure you have this one copied into your notes if you need to, and we're moving on to our next problem. So in this one, we have it set up a little differently in that we have a number by itself on one side of the equation. So first, we want to know what x's we can't use. So x cannot equal -1 from this denominator and +2. Our lowest common denominator would be x plus 1, x minus 2, and 1. And so we have that, and that's what we're going to multiply our whole equation by. So we're going to multiply it by x plus 1 times x minus 2 over 1. And so that means what that's going to look like is that we're basically going to have our x that we started with in the first numerator times both things we just added to it over that same denominator. And then we have the same thing basically with our two things on the top added to it and the same denominator. And then we have 2 times both of these things. Okay, so we have that set up right there. So now we can cross off and divide out some things we can get rid of. So x plus 1 and x plus 1. And this is supposed to be a -2. So we can get rid of the -2 and the -2. Those match each other. But then the end fraction doesn't have anything we can get rid of. What that leaves us with is x times x minus 2 plus x times x plus 1 equals 2 times x plus 1, x minus 2. So we have that set up right there. And if we are now just going to multiply everything out and combine like terms. So starting on the left here, we have x squared minus 2x plus x squared plus 1x equals 2. I'm just going to multiply this all out inside first. So we have that. And then we have 2x squared minus 2x minus 4. And then we can just combine like terms over here. So that would give us 2x squareds and then minus 1x. All right, so lucky for us, we can see we have a 2x squared on both sides. So no quadratic solving for us this problem. And then we're just going to add 2x to both sides. So that means that 1x is going to equal -4, or just x equals -4. And that wasn't one of our excluded numbers, so that works great. That is our solution to this equation. And I believe that was problem 4, so we have one more we will do together in this video. So make sure you pause here and copy down these steps if you need to. And now let's move to our last problem. So kind of similar to what we just did, we're basically going to be looking for the numbers we have to exclude first. So we are excluding 0 and positive 1. And our lowest common denominator would be x and x minus 1 together. So we have that, and then we're just going to multiply everything by that common denominator, like so. Okay, so now we on the first fraction, we have 6 times our common denominator. And we have the same x on the bottom, minus 2 times our common denominator, and x minus 1 on the bottom, and then 1 times our common denominator on the top with a 1 on the bottom. And we can now cross out and divide out the things we have in top and bottom. So x's are gone, x minus 1s are gone, and that leaves us with some stuff to simplify, which means we have 6 times x minus 1 minus 2x is equal to x times x minus 1. So we'll simplify again. So now we have 6x minus 6 minus 2x equals x squared minus 1x. And we just got to solve this for x. So we'll move everything to the side with x squared on it. So that would leave us with x squared. So adding 2x to both sides, we get 1x over here. Subtract 6x, we get -5x. And then adding 6, that should be an easy one to factor. We're just adding up to -5 and multiplying to 6. Those two numbers are -2 and -3. And so that means that our answer for this problem is 2 and 3. And lucky for us, neither of those were excluded numbers up at the top here. They were just when it was just 0 and 1. Well, 2 and 3 aren't one of those. And so that means that we have finished the problem. We found the 2 possible answers. Always a good idea to check your work along the way to see if you've made algebra steps by plugging in your answers back into the original problem. But as long as you don't have an answer that's one of the extraneous ones, if you think you did it correctly, then that's kind of the main concern, that you're not providing an extraneous solution when there is one. And that is how you can solve rational equations. This, I believe, is the easiest method. There are other methods out there. Like for this problem, for instance, we could have done the subtraction first and then cross-multiplied. But I really believe that would cause you'd have to do more steps, and it's a little bit more complicated, I think. So this would be, I believe, the easiest way, in addition to the graphing method that many people would probably implore as well. And that concludes this video on solving rational equations. Thank you for watching.